right, so this is going to be the lecture for February 9th. This is an A-Day. So we are going to be looking at acceleration today. That is our main focus. So the one topic with acceleration we have to really make sure we pay attention to is acceleration, velocity, and speed get used interchangeably so many times. While they are similar in meaning, they are not the same thing. So when we are looking at speed, acceleration, and velocity, we need to be able to pick apart the differences. So speed, we have a couple definitions. I think it was about 2 weeks ago in our notes, we know that speed was equal to distance over time. We know that speed can be measured in meters per second, miles per hour, or even kilometers per hour. So those are your units that you can typically see. Acceleration is a little bit different. Acceleration does mean that something is going, but it doesn't necessarily mean that it is moving anywhere. So if you would like to envision this as an older car, and let's just say it's kind of like a car that can shift. You know, it has the little joystick kind of looking thing in the middle, and that particular device is actually called a clutch. If you put it in neutral and you put it between all the other gears where the car is on, you can actually click on the accelerator and you can hear the engine begin to just roar. It just makes a lot of noise. But the car isn't actually moving anywhere. So at the same time, as you're pushing down on the accelerator, the engine is going up, and you can actually look at your dashboard on the car, and you won't see the miles per hour thing. You won't see the speedometer move, but you will probably see some gauges off to the side kind of go off. So there are differences in acceleration and speed. Acceleration means that you have the force and ability to create speed. That is your straight up, super easy definition of that. Speed we know is kind of going fast. Acceleration is where you have the force and ability to actually create speed. So again, speed is actually moving. Acceleration is kind of like that car that's in neutral. That engine can roar, it has the power, it can go, but it's not actually moving anywhere. So that's for that example. A car in neutral with a foot on the gas pedal. Like I said, I'm trying to keep everything super, super easy. So if you're into cars, I apologize if you feel any insult on that. All right, next up is going to be our velocity. Velocity is going to be equal to acceleration times time. So let's go ahead. I'm going to move that out here. Velocity will be equal to acceleration times time. And here we go. Velocity can be positive or negative. Speed will only ever be positive. So velocity is talking about speed going backwards or forwards but speed will only ever be considered positive. Or if you want to have a math term to it, you can consider your absolute value. Maybe it doesn't have a positive or negative to it. It's just an absolute. Here's your number. So let's look into our units for acceleration and velocity. Velocity will kind of have the same units as a speed. So you will see units here. Acceleration, though, you'll have meters per second square. That will actually be your units for acceleration. All right, so I want to make sure that we have all of our different formulas. So I'm going to go ahead and make a little section right here. And we're going to write out all of our formulas from the beginning of this unit. The first formula we have is force is equal to mass times acceleration. We had a triangle that looked like this. Remember, if you are trying to dissect this, the long line right here means division. The little up and down, that means multiplication. So force, cover up F, M times A. Mass times acceleration. Trying to find mass, force divided by acceleration. Our next equation was speed is equal to distance divided by time. Our triangle here for that one is here. If you're trying to find distance, distance is going to be, cover up D, speed times time. Okay, and our last one was going to be for acceleration. Acceleration will be equal to our velocity divided by time. So again, velocity would be on top, acceleration and time would be on bottom. So for those that need every little bit kind of marked out for them, let's go ahead and denote each variable. F is going to be equal to force. M will be equal to mass. A is your acceleration. D is equal to distance. S is equal to our speed. V is equal to our velocity. And T is equal to our time. Please be very careful. Speed and velocity, they do have the same units. Sometimes they can be used interchangeably. Please remember that speed is kind of like an absolute. Velocity can be both positive and negative. So sometimes when it seems like they're talking about speed and you're not able to see different variables, they may be talking about velocity instead. So make sure to have these written down, which is why I'm going to make a pause. There should be a note here actually telling you to copy this down. All right, so let's go ahead and let's go into an example problem. So example 1. I'm not going to have anybody write out all the details here. I'm going to tell you as we're going along. So our first example, we are going to have a little boy who's trying to push his red wagon up a hill. And his little red wagon weighs about 12 kilograms. And since the boy is trying to push the wagon up a hill, we know that there is a force involved. So his force is going to be realized as 6 newtons. And please remember that newtons has a unit of N. That's how it's abbreviated, N. And so the question is asking, what is the little boy's acceleration? So I can look and see what I have. I see that I have a force, I have a mass. So I know that I'm going to be using my F equals ma. So a lot of these equations, they are plugging in values. So again, I know I'm using force and I'm using mass. So that's how I know I'm using this equation. So F equals m times a. I will rearrange this. I know I'm looking for acceleration. So I'm going to cover up a, and I know that my acceleration will be equal to force divided by mass. So let's go ahead and plug in the numbers. My mass is 12 kilograms, so I know that my mass will go on bottom. And my force will go on top. And so I would need to use a calculator and calculate this out. So we know that 6 divided by 12 is equal to 1/2. And we know that 1/2 can be written out as 0.5. Now, the units are right here. Your units should be newtons divided by kilograms. So here's the second part that I would really like to point out. While we have newtons over kilograms, again, some of y'all who have been paying really close attention said acceleration is supposed to be meters per second squared. So why isn't this our units? Well, here's the thing. Newtons can cancel out with kilograms, and it's actually left with meters per second squared. So both of our units here are actually correct. So both of these are going to be okay. All right, last but not least, we're going to look at something that is called displacement. Displacement. So displacement is going to be a relevance of movement to an origin. So our definition that I've been writing out is that displacement is a distance from an origin. That's what displacement means. And so I'm going to draw out, I have my little mailbox here, little flag. All right, so here is my mailbox. And let's say I'm standing right next to it. So if I move, I know that I moved because right here. If I moved away from the mailbox, I know I moved because I'm moving away from something. Generally, I would be asking, how would you know that somebody moved? A lot of our answers that we get is, your voice sounds further away, or I used my eyes. Duh, Miss Kang, it's called watching something. So here's where we really need to actually pay attention. Make sure to use your place of origin. So if I'm moving away from somewhere, I'm going towards the front of the classroom, I'm going to be moving away from my desk. I would know I'm actually moving because of this particular object. So I know you're moving around your bedroom because you're either moving away from or towards the door or from side to side. So here's the thing about displacement. Displacement can be positive or negative. So if I have positive, that means I am moving forward. If I have negative displacement, that means I am moving backwards. So if I'm moving forwards, I would have a positive 5 meters of displacement. If I were to move backwards, let's just say that would be a negative 3 meters of displacement. So we'll probably be looking more at these problems next class. Today's assignment is really going to focus more on our calculations and our use of equations here. I believe there's only 7 questions. 1, 2, 3, 4. No, there's only 6 questions. So there's only 6 questions with today's homework. You're not going to look at 1 and B. So yeah, 1B and the extra credit questions. You're not going to look at those. Extra credit, don't do those, mainly because I haven't given you the formula. So there's no exception for that. And then 1B, it's asking you to convert speed into miles per hour. Again, I haven't shown you how to do that, so I'm not going to ask you to do that. So if there's any questions about today's assignment, please let me know. But other than that, make sure you have a good day.